In this video, I'm gonna go over a very brief introduction to linear regression. We're gonna talk about the objective of linear regression, and we're gonna talk about the main issues that we're gonna cover in this chapter. So in a lot of business applications, whenever we're dealing with planning, especially, we need to make forecasts for the future. When you want to run a promotion program, you want to know what would be the effect of that on your sale. When you're running a marketing program, you want to understand what would be the effect of that on your cost, on your sales, on your profit at the end of the day. When you're developing a new product, you want to know, you want to forecast the sales, the demand for that product. When you're establishing a new branch, you want to know how much would be the demand, how many people are going to come and buy your product from that specific branch. When you're hiring someone for a new position, you want to make a, you basically, before you can go ahead and hire someone, you need to make a forecast on their performance, how they're going to perform in that specific position. So in all these examples, we need to make a prediction in the future, right? So we need to forecast a variable that is going to happen in the future. So one way to do that forecast would be to use the regression analysis, which is a statistical procedure for developing an equation that connects the variable of interest, which we also call it dependent variable, whatever we want to predict, whatever that we are interested to know. In a lot of cases in business, that would be sales and revenue. We just connect it. We just try to explain that variable using other variables that we believe are related together. So when we develop a linear or nonlinear equation that shows the relationship between some independent variables with one dependent variables, that procedure is called regression analysis. So we are trying to develop a regression that a linear equation that explains that explains the relationship between sales and promotion program, between sales and marketing program, between demand and a new product development, between, again, demand and sales or revenue or profit and the population, for example, population of a new county that you're establishing a new branch. Performance of a person based on some characteristics of that specific person for a specific position in the company, right? So this is what we want to do. We want to develop an equation that explains the relationship between one or multiple variables with one specific variable that is the most important one to us. We want to predict that one, right? So I'm just going to go over some basic definitions and basic terms that we're going to use a lot in the linear regression chapter. So we have dependent variable or response. This is usually one variable. In all cases that we're going to go over in this chapter, we only have one dependent variable. Always one dependent variable, always. So that would be the variable that we want to predict. That would be usually sales or revenue or profit or performance. So these are the types of things that we usually are interested to know, are interested to predict in the future, right? The second group is called independent variables. So these are the variables that we use to make prediction about the dependent variables. And these are usually the variables that we believe that they're associated with the dependent variable, right? So they're also called predictors, predictor variables. For example, if the dependent variable is sales in, let's say, in the next month for a company, the independent variables can be anything that, I mean, based on experience, you know that they can contribute to the sales. For example, the money that you spend on commercial ads, for example. The number of employees that you have, the number of branches that are operating, the number of products that you're selling to the market, and so on, right? And then what we do in the linear regression, we try to come up with a linear equation that connects this dependent variable with, I mean, one or multiple independent variables that we believe are associated with the dependent variable, right? So we use y usually for the dependent variable and x to demonstrate the independent variable or variables. Depending on the number of independent variables, we may be dealing with simple linear regression or multiple linear regression. So when we have just one independent variable, it's called simple linear regression. So we have one y, one x. When we are dealing with multiple independent variables, that would be called multiple linear regression. So we'll be dealing with y and multiple, one y, but with multiple x's. So we're going to talk about both of these cases. And again, in this chapter, we are going to be mostly dealing with linear regression, but regression analysis doesn't have to only deal with the linear one. So it can also be about the nonlinear relationship, which we also are going to cover the quadratic, which is a specific type of nonlinear relationship. So it can be simple, it can be multiple, it can also be linear or nonlinear, right? So this slide summarizes all you need to know after covering this chapter. So this is actually the typical steps that we need to take in any linear regression analysis. So first of all, you have to have a clear question. You need to know what is your dependent variable and what are your independent variables, the variables that you're going to use to make prediction about your dependent variable. Then you can go ahead and collect sample data, which is in our case, in our course, usually provided to us. So we don't need to really go and collect data. Data is already given to us, but determining dependent and independent variables, it's up to us. Next step would be to estimate the relationship. So what we want to know at the end of the day is the true relationship between x and y, between y and x or x's. We want to understand the true relationship between x and y, but in order to be able to do that, we're taking a sample and we are estimating the relationship. We are approximating the relationship coming from a sample, coming from sample data. So we're going to use least squares method. We're going to talk about the details of that. We use that to estimate the relationship and we find the estimated linear equation. So we find this estimated equation and we need to be able to interpret the coefficient of the linear equation. And also, with respect to the estimated line, we also need to be able to comment on the strengths of the relationship by assessing the goodness of the fit. So this is about the estimating the relationship, coming up with an estimation. Then we need to be able to make a conclusion about the true relationship by checking the necessary conditions for residuals and also checking for multicollinearity. And once we have all these prerequisites, we can go ahead and conduct statistical inference and make some conclusion about the true relationship. Because at the end of the day, when we're conducting linear regression, this is the true and genuine idea behind it. We want to make some conclusion about the true relationship. So the sample by itself usually doesn't have a value. At the end of the day, this is what matters, this statistical inference about the individual parameters. Individual parameters, I'm talking about every single independent variable and dependent variable, the relationship between every single independent variable and the dependent variable, and overall fit, the overall relationship between the dependent and all the independent variables together. So we're going to talk about the details of that. And then the last step would be basically comparing multiple regression models. So in a lot of cases, you can run a simple regression, you can run multiple regressions, you can run linear regressions, nonlinear regressions. You may have 2 independent variables, 3 independent variables, 10 independent variables. So which one of these models are going to be the best regression model that you should actually use it in practice? So we're going to talk about different criteria that are going to be used for selecting the best regression models.